Hello everyone, I'm Andrew Freeman. I'm an assistant professor of computer science at Baylor University. Excited to share our work on content moderation with MoQ, kind of a unique application, I think. For the sake of time, I'm going to spare some of the more academic and technical details, but we have a full paper that will be published in the proceedings of this conference if you want to take a look. I don't think it's available yet, so if you want a copy, you can just send me an email and I'd be happy to share it with you. So the motivation for this is we've been using MoQ for a while, kind of from a research perspective, kind of seeing what unique things we can do. And so we started to try to think, not everybody actually needs this ultra low latency that MoQ promises, right? WebRTC also promises ultra low latency, but a unique feature of MoQ is that we have potentially tunable latency. So we can have super low latency and also video on demand and everything in between. So we were trying to think of a unique application that could benefit from this tunable latency trade-off. So CDNs definitely need ultra-low latency, but every end user doesn't necessarily need that. If you're doing like live teleconferencing, you need that. If you're doing one-to-many live streaming, maybe not necessarily, depending on the type of content. So that's what we're trying to exploit. So if a user is willing to sacrifice some level of latency, what more can we offer them? What can MoQ bring that other protocols could not, or at least could not without extreme difficulty and modification? So that's kind of what we're coming at this from. So what is a compelling application that has a tunable latency trade-off? Well, we think content moderation is one of those applications. So automated content moderation for traditional video streaming is very difficult to scale. There's a question of which of these live streams should be moderated. What are the moderation rules around this? That's going to be platform dependent. And what is a tolerable impact on latency? So with traditional systems, there will be kind of server-side moderation. And if that is very intensive, it slows down the stream for everybody. So everybody incurs higher latency. But with MoQ, we don't have to do that. That's the teaser here. And then also traditional moderation is a one-size-fits-all approach. So one of these streaming platforms will have a set of rules, and a stream will either abide by those rules or will not. But those rules might not necessarily be what I would prefer, right? I might not want certain types of content in the video stream, even if the platform says that they're okay. The platform rules tend to be relatively loose on some certain things. And as a parent, this is especially kind of relevant for me as I'm starting to think about, what kind of content I want my kids to be exposed to as they grow up. So I'm gonna, we've already kind of introduced Media over Quick, but just as a quick comparison to the more traditional protocols, HLS and Dash are inflexible largely for automated content moderation. From what I've seen, any level of content moderation on these like large live streaming platforms is still done by humans. So it relies on people reporting a stream potentially as having bad stuff happening in it, and there will be a human reviewer. Or if there's automated moderation through computer vision applications, it's for some very basic stuff, very lightweight, so as to not reduce or to not increase the latency. Media over Quick, meanwhile, is, as we've seen, an in-progress transport protocol that people are working on to enable low latency streaming and VOD and everywhere in between with a single transport. So it's push-based. And what we're leveraging here is the bidirectional communication, which I don't think the last two talks have talked on too much. So our idea here is that we can have a number of granular content categories. This could be infinitely scalable theoretically. And we're actually going to distribute the analysis of the video content to the edge playback devices. So the actual clients that are watching the video can actually contribute their compute resources to analyze the video for other people to have very granular moderation. So we can define all sorts of different categories. I have a couple examples that we've explored here. So epilepsy risks, so flashing lights that could cause seizures for people with photosensitive epilepsy. We could detect that and block that for people that are prone to those risks, not block it for people who aren't. Smoking, if you don't want to see that kind of content. Violence as well, nudity is an easy one. And then there are a lot of things that I probably can't think about or think of that other people might have ideas for that they want to block, and we could build it and add that support. So the individual users then can decide what they want to filter, and that content will not appear, or it could appear blurred or modified in some way to change the viewing experience. And they will incur some added latency, but we can really minimize that latency penalty. And users that are not filtering any content will have no latency penalty whatsoever. They can still be at the very live edge of the stream. Oh. Okay. I think I made a mistake going back. Okay, yeah, we have a demo here. It's not as impressive as Ali's, but this is a proof of concept. We have multiple clients that are receiving the same webcam stream. One of these is going to be just viewing it. Another client is the strobe analyzer. And then this client in the middle is going to be filtering on strobing content. So we can see that the one that is filtering here in the middle, it has an added latency of 1 second, which is our GOC duration here. So it can, the other clients will potentially detect the strobing light. Now we have 2 filtering clients. Those clients have a slight latency penalty, and we just don't display those flashing frames. And then as soon as that impulse is removed, they can continue watching the stream. But other types of content categories might not just stop the frames, but it could modify the frames in some way, blur it or blur part of it, draw annotations over it, things like that. Okay, so we propose a few components for this in the paper in terms of the design. This is still in the very early design stages, so we're open to feedback. But we can carry all of these analysis results along a dedicated track for metadata. And we also define a workflow manager, which is going to be responsible for actually delegating the analysis tasks to the clients. So we don't want a client that is filtering data to also be analyzing it. So we want the analyzer clients to just be normal viewers. We can leverage their compute resources in the background. And if we do it in an intelligent way, they're not going to notice. It's not going to have an impact on their battery life if it's on their phone. And yeah, we can sort of orchestrate all of this analysis. The filter decision engine was a unique thing that we started to think about, because if we are running these analyses in the web browser, that's not something that we have full control over. There's a risk of a malicious client coming in and giving us false results and sending that back to our system. So we started to explore what are some of the security risks in terms of if we have this number of malicious users that are analyzing content, how can we overcome that to a sufficient degree? And different video platforms could decide for themselves what a tolerable amount of risk is. But really we see that if we just have a slight redundancy in the analyzers, we can overcome any realistic levels of malicious attacks. So yeah, we're starting to explore those kind of security risks that come in with this. And then we've also started to sketch out how we can handle this with a large multi-relay topology, so like on an actual CDN. And with the workflow manager is just very deliberate and intentional about where it delegates the analysis tasks. We can really minimize the added latency. So you want the analyzer clients to be upstream of the clients that are filtering for a certain category, and then you can leverage the fact that the metadata is going to be super lightweight, just some light JSON probably. We can transmit that much more quickly than the video data, and really we have almost no latency above the analysis time, which is going to be roughly real time for these applications, and the normal relay-to-relay propagation. So the potential impact here, in my opinion, is I think there's some good societal benefit that we could work towards accessibility for people with photosensitive epilepsy, like I said, and also just content safety, especially for minors and children who we don't want to expose to bad content, right? If somebody is streaming on Twitch or Instagram, we have no guarantee of what they're going to do in 5 seconds, right? And we need to be able to detect that and immediately shut that down or blur it or do something like that in some way to protect, the stream experience. We can also increase the personalization, and this kind of goes into the mixed use cases note here. We don't have to just use this for content moderation. We could sort of abstract this and think of it as just a distributed edge AI system to improve the video experience, the video streaming experience. So we could also use the same system to do like live sports analysis, kind of generate some of the stuff that Ali was showing in his demo, run that on the edge clients so that the video provider doesn't have to pay for that server. We're offloading that cost to the users. They're not going to notice because it's distributed. We could have, clients processing one frame every 30 seconds, but we parse that over the entire system, allocate those results, bring it all together, and redistribute those that metadata. It's relatively well understood in terms of the distributed systems literature, but the very unique part is that we have potentially very high failure rates and high dropout. If a user just decides to drop out of the stream, then we have to deal with that in some way. So really interesting research challenges in terms of the distributed computation, but it's nothing out of the ordinary, nothing that has not been tackled before. So we just need to bring that to the video streaming world, and we can do some cool stuff. And then also, if there is any video platform that is currently doing live stream content automated like moderation, if we offload the computation, we can reduce their cost. So a pretty simple win there. And then I also see some potential new commercialization opportunities. So you can think of like moderation as a service. Like if I could pay an extra $3 or $4 a month and guarantee that all of the video content my kids are watching is not going to have explicit language or nudity or violence or anything like that, I would happily do that. It's like $60 a year. I'm willing to do that to ensure the safety for my children, right? And also, if you're really into live sports, you could get all these cool sports analytics on top of your experience and pay a little extra for that. And this adds no cost to the CDN or the video platform. Oh, wrong button. Okay, so the next steps that we're looking at are pursuing compatibility with MSF and CMSF. So we can probably use the event timeline track that they're defining there and transmit this data over that event timeline. And then we also want to release an IETF draft specification to start to solicit feedback. So this will hopefully come in the next month or two. I'm awaiting final approval from Baylor's IP office, to kind of sort out the details, but I don't expect any problems there. Then we want to pursue a full open source reference implementation that we can share with everyone, and then start to build up a suite of mobile optimized AI analysis applications. When I was digging into this, I was surprised by just how powerful our phones are. I can do real-time 30 FPS image classification on my 3-year-old phone, and it really has no significant impact on the CPU usage or anything. So we have these powerful resources, and if we have dozens or hundreds or thousands of people watching a live stream, we could use those idle resources and actually improve the experience for everybody. So that's kind of the goal here. So that's all I have. Thank you.
Thanks. Okay, I got one quick question.
Yes.
So what part of MoQ that make it more friendly to automatic content modernization than today's HTTP-based stream?
Yeah, that's a good question. So it's primarily the bidirectional communication. So we can receive video data and also send arbitrary data back to the relays. And it has no added cost. We don't have to set up a new connection. We don't have to configure HTTP servers with a lot of potential security risks there to just allow arbitrary push requests. We can just send data back across the same quick connection that we already have set up.
Good, thank you.
Yep.
I have a question. So from what I understand, this assumes that you can run those filters locally so that you can then share the output of them with others. Mm-hmm. So if you can run them locally, do I understand correctly that the advantage of the scheme is that you can run more filters?
Yes.
And
yes.
Different clients run different filters?
Yes, exactly. Yeah. So the system would only run the analyses for things that are actively being filtered that people actually want to, detect and block or, respond to in some way. So the analyses are going to kind of scale up with what people are actually demanding, and we could have dozens or hundreds of different, very particular content categories that we're analyzing for filtering. So you can have super granular personalization on how you want your streaming experience to be.
Okay, thank you.
Okay. One more question, if any. Otherwise, next presentation. Okay.
I don't know if that's a good idea.
Is there a mechanism in MoQ on the relay side to enforce a specific user to have a higher latency? Suppose I have a really smart kid who tempers his client to reduce his latency so that he can see all the smoking and violence.
No, so it's a good question. I'm pretty sure that the implementation is going to have to be in the player side. So a user might receive the video data, as soon as it's produced and comes through the relay, but they might not display it until they have received all of the associated metadata for the content categories that they're trying to block or respond to. So just kind of player side buffering, modify the player or create a player for this. Don't touch the relay at all. That's kind of the general idea. Use a normal MoQ relay with no modification. The other components will kind of be kind of sidecar server processes that interact with the relay just to distribute other metadata throughout the system.
Thanks.
All right. Thank you.
Thanks again.